It's simple mathematics. Check it out. I revolve around science. What are we talking about here?
Okay. Over the course of the week or so, we've gotten back into algebra and looking at solving equations. So I'm just going to review some of the things that we talked about here, and maybe some new things that we didn't really talk about, mainly for the sake of time, but show you how it works. And a lot of it is going to be review from term one, just adding in the equation part of it. Okay, so I just want to look at this pattern here, and if we look at the first term, second term, and the third term, we see that there are one red block and two green blocks, and then we have the one red block and then four green blocks, and then the one red block and six green blocks. So if we look at the transition between the patterns, we can see that it's skipping by, go a little lighter here, skipping by two and then two more. Okay, so we can kind of add this information into our table of values over here. If we look at our first term, it has a value of 3, and then our second term has a value of 5, and our third term has a value of 7, and then our fourth term, if we kept this pattern going, we'd end up with skipping by 2, so therefore we'd end up with 9. Okay, and if we see that we're skipping by 2 each time, we have found ourselves the coefficient of 2 for each term. Okay, so if this is any term, we have a coefficient for each term, and then we can look at where we started. If we go back to, we should start at 1. Okay, so in this case, our algebraic expression is 2n plus 1. Okay, so that's a little bit of a review how we get the algebraic expression. The adding to each term number, add to each term number is saying I'm going to repeat add or multiply by the term number. Okay, and then I'm going to add where my pattern started. Okay, and if we thought about where this pattern started prior, it should have started with one red block, and that's the part that stays the same. Okay, so now we want to suppose that we are going to use this to solve. So let's suppose that we have our pattern is 2n plus 1, which is equal to, let's say, 35. Okay, so now supposing we want to figure out, we want to know where in the pattern will we have 35 blocks. Okay, that's what this question is asking here. Okay, so we can sort of take a guess. Okay, 2 times the number. All right, 2 times the number to get close to 35. So we could take our first guess. Let's say we want to go 2 times 15. So we're going to go 2 times 15 plus 1. All right, now this equals 31. Okay, so obviously this isn't close. All right, so we need to get a little bit closer. How much closer do we need to get? Well, we need to get closer by 4 almost. Okay, so we have to think about another number that's going to get us closer by 4. All right, so now maybe we try, so we tried 15 and we got really close. So maybe we try 16. 2 times 16 plus 1. All right, so now I end up with 32 plus 1 equals 33. Okay, so I'm slightly off, but I moved more 2. Okay, so then on our third guess, all right, we have to get something that's slightly closer. All right, so Now we're going to try 2 times 17 plus 1. All right, so if we do 2 times 17, times 1, 7 equals 34. All right, so then we add that 1 and we end up with 34. So we have our correct, oh, so we end up with 30. Sorry. We end up with 34 plus 1. I forgot to add the plus 1, so we end up with 35, and therefore we have found our correct answer, okay? Now this strategy is called trial and error, okay? Now, we kind of put in we kind of looked at inspection too, because I looked at this and said, okay, what do I need to multiply 2 by to get close to 35? And that gave me my first guess of 15. And then I tried a bunch till I got the right answer. Okay, so we can use trial and error, but we used inspection, okay? But we can also look at doing a balance model, okay, to actually solve it out, because we need to kind of solve. So balance model. Okay, and the idea here is that we are going to keep each side balanced. Okay, at the same time, we are going to get the variable by itself. Okay, so alright, so that's going to be our goal. So now let's look at our 2n plus 1 equals 35. Okay, so just like we did up here, we had to multiply 2 by a number and then add 1 to get the answer. Okay, so now we need to look about as if we're working backwards, all right, to find the missing number here. Okay, all right, now we already know the answer, but we're going to go through it anyways. Okay, so I kind of want to get rid of the parts. So my last step was to add 1 to get to 35, so I kind of need to work backwards. So I'm going to go 2n plus 1, but I want to get rid of this plus 1. I can do that by subtracting 1, which equals, but what I do to one side, I have to keep it balanced. So what I do to one side, I do to the other. And then we end up, you can see that the 1's here cross each other out. I'm left with 2n is equal to 35 minus 1. So I end up with 34. Okay? Now, this says 2 times n is equal to 34, so I need to get rid of the 2 times n. All right, I can get rid of a times 2 by dividing by 2. All right, and if I see that, these two cancel each other out, and therefore n is equal to 34 divided by 2. All right, and if I pull out my calculator, 34 divided by 2 equals 17. So then we have 17. All right. Now, whoa, oops, that's not what I want. That's not what I want. Brush size. Okay, so sorry about that. Brush size. That's what I want to do. I'm going to erase it out. Okay, I'm just going to give me some space over here. Okay, we need some space. Okay, so now the last step, okay, is going to be, okay, now that we saw this answer, we need to check our answer. Okay, so how do we do that? we need to check our answer. So we end up putting in our, what's going on here? All right, 2n plus 1 is equal to 35. Now we're going to take our answer and put it in for the n. So we're going to go 2 times 17 plus 1 is equal to 35. And then we use our calculator and we start solving, okay? 2 times 17 equals 34. So we got 34 plus 1 is equal to 35. And then we add the 1 to the 34, and we know that we get 35 is equal to 35. We can say that left side is equal to right side, and therefore we're correct. Okay? So this is balancing and checking. Okay? It's a little bit more efficient than the guess and check that we did above. Either way, all right, we have solved for this equation. Now let's remind ourselves that the equation is simply an expression that I've highlighted in red here. Expression, okay, with an answer. Okay, so equation, okay, simply with an answer. You can think about it that way. Okay, and therefore that's kind of how we solve equations using different strategies. I hope that helps, and keep practicing so that you'll be ready for the test when it comes up.
It's simple mathematics. Check it out. I revolve around science.